maybe Microsoft Paint is not the right tool for this.
I will not entertain that.
Real programmers use Notepad and real presenters use Microsoft Paint.
Welcome to another episode of ArrayCast. I'm your host, Conor, and today we have with us 4 panelists. We'll quickly go around and do brief introductions and then hop into a couple announcements. So we'll start with Bob, then go to Stephen, then go to Marshall, and then go to Adam.
I'm Bob Therriault. I am a J enthusiast. I'm not a professional programmer. I'm working on the J Wiki, and that is keeping me really busy.
I'm Stephen Taylor. I'm a Q and APL programmer, and I also run something called Iverson College.
I'm Marshall Lockbaum. I'm a former J programmer. Then I worked at Dialog, and now I make BQN.
I'm Adam Brodzewski, full-time at Dialog, doing APL programming and teaching.
And as mentioned before, my name's Conor. I'm a research scientist / C++ developer at NVIDIA, and in my free time, I'm a huge array language enthusiast. So I think for our announcements, we're going to start with 1 announcement from Stephen, then we'll go to 3 from Adam, and then I've got kind of a postfix update on the meetups, and then we'll have another postfix thing by Bob, and then we'll hop into today's conversation.
Okay, on Sunday, the 25th of September, from 2 to 4 p.m. London time, Iverson College is holding an online workshop session on getting into vector programming. This is for Q programmers who've made the transition from some other language to Q, is looking for how do you do things in a vectory way? How do I do things without loops? How do I make sure that I'm using the facilities of Q for iteration? If you'd like to join this, please contact me personally. My email address is very short. It's sjt, that's Sierra Juliet Tango, at then the number 5jt.com, sjt@5jt.com. That's Sunday, the 25th of September, 2 to 4 p.m. London time.
Right, then there's a new thing in the APL world, yet another new thing called the Jot.Times. It's actually a revival of an old APL newsletter title, but you can find it on apl.news. That's the whole URL. And it's basically just a news aggregator for blog posts and other things that are published around any type of APL and APL dialects. Then I have this weekly thing going on called the APLQuest, which consists of a meetup in the APL Orchard chat room. And the people who are there are fairly advanced. And then I make a follow-up video to that. And based on feedback, I've now started to lower the level to be really introductory. So if you're completely new to APL and array programming, these new videos, beginning with the one that's the last, or by the time this gets out, will be the last couple of videos. It's the 2016 round, I think. Then everything will be explained, so you should have a good chance of being able to follow along. And finally, there's a user group called APL in Barcelona, and it's global, despite the name, for now at least. And they're just starting a new 4-part series of meetups. The first one is September 17th, so you might just make it if you hear this as it comes out. And it's a discussion on Iverson's notation as a tool of thought. That might be something interesting to participate in. All of this, of course, goes in the show notes.
Awesome, yeah. And I would highly encourage folks to check out the APL.news, aka the Jot.Times. Do you know who runs this? Because it's pretty cool.
Yeah, I mean, it's one of my colleagues that has set it up, but on this.
And I had no idea that Paul Mansour has been, I guess has his own blog and has been solving little LeetCode problems just in blog style. And they're very nice to look at because they have the correct Unicode font, etc. Anyways, some things that I did not, I recognize some of the articles in here. I've definitely seen them, but not all of them for sure. So
you might want to check out also the APLwiki has a page called blogs, and it lists all the blogs that we know of that publish APL content.
Awesome. Yeah. We'll throw obviously links for all this stuff in the show notes, but definitely cool to be exposed to content. Like I didn't even know about this. So getting to learn things from my own podcast. Fantastic. The thing that I wanted to mention was just a kind of a short recap. So if you're a regular listener, you will know that I helped run along with Morten Kronberg and Dialogue and a couple other presenters, Lib Gibson in the Toronto Meetup, and then Josh David in the New York Meetup, who've been both guests on past episodes. We had the two APL Meetups, so September 1st was the Toronto one, and September 7th was the New York one. Just want to say thanks to all the folks. If you happen to be a listener and you came out, it was a ton of fun from my point of view. I got to meet not only Josh and Morten, who have been past guests on the podcast, but also a ton of other folks that over the last 2.5+ years that I've basically sort of entered the array language community. Folks like Rohan and Rick Proctor. I'm sure I'm forgetting a few names. And I have met a couple people that were also there. Devin McCormick I'd met before. But anyways, just awesome to meet people in person. And then outside of those meetups, I got to have a couple, meetings with folks, that either were or weren't at the meetups that were in New York or in Toronto because people were, in town and close. And hopefully, I think I talked to Morten and we might be doing something like this going forward, not necessarily in Toronto and New York. We might try different cities, but maybe once a year or maybe 2 times a year to try and do something like this, which would be super awesome. And for folks that weren't able to attend in person, my talk will be re-recorded and posted on my YouTube channel this coming Saturday if everything goes going to plan. So if you're listening to this, it will probably already be online, or if not, in a few hours, it should be online. And I know that Morten is planning on re-recording, and we did manage to record Lib Gibson's, and we're going to be trying to put that online somewhere. And Josh Davids from the New York Meetup said that he plans on giving his potentially at a future conference like Appleseed. So all of the different talks should be hopefully available at some point in time. And whenever they become available, we'll make sure that we have links in the show notes so that people can check them out if they're interested.
When you do your talk, are you going to do it live like you did the last time with people watching? Or are you gonna...
I don't think so. I will do a premiere version where I'm in the comments answering questions, but it is my observation that a pre-recorded premiering talk does better metrically, aka with views afterwards, than a live talk does, because I think people view it as a live stream, and also you have less control. Like you can monitor your time, but if you're pre-editing and polishing it, you can make sure that it's nice and tight. Whereas my last live stream ended up, I think part of it was that it was a 2-hour talk, because I realized, I can just go as long as I want. As people, if they're interested, will drop off or not drop off. But yeah, that's a long answer to what could have been a short answer. No, it won't be live, but I'll be in the chat to answer questions. And potentially if folks want, I can think about setting up like a Jitsi or a Zoom if they want to do like a live Q&A after, to sort of replicate the fact that I can answer questions live in a live stream. That is the one advantage, that there's a little bit of an opportunity to do more interaction.
So I've just managed to create a whole bunch more work for you.
Yeah, it's okay. Setting up a Jitsi link at the end is not too much work. So anyways, from that, we'll skip over to Bob, whose, I think, last sort of announcement and conversation will bleed into today's topic, which we'll mention in a sec.
Well, my announcement, and it's, you often see these lists of programming languages and how popular they are and everything. And in the most recent IEEE Spectrum list, J shows up. And depending on, when I did a really quick count of the number of languages they had listed, it was 57, which, I don't know, it's kind of a weird number. And J was 6th from the bottom. So we're either 51st, or if it was actually 50 and I've just missed by 7, then we're 44th in the list. But in any case, J shows up, APL doesn't, and K doesn't, which surprised me. But I always wonder about how they're doing these lists. And but in any case, J does show up, and hooray, wonderful. I guess we get a participant's badge or something. I haven't received anything yet. I don't know whether Eric has. But we're on the list. And so if that makes a big difference to you as a listener, well, then we've made the grade, and you can study the language in comfort knowing that we're not complete renegades. And I guess there's There is we've overcome that obstacle of being a single letter language and actually showing up on the list, because
That may be why you showed up.
what do you think? They only had space for J?
It goes one way sometimes and the other way sometimes. So,
Well, I mean, C is on the list. There's multiple one letter. There's C, there's D, there's R. I think those are the only.
all right, if they had V, it would be very suspicious.
V. Oh yeah, that's a brand new, or that's a nascent language. Yeah.
Yeah, because nobody uses V.
Yeah, we'll leave a link to this. I'm not sure if everyone in the recording right now has a link to this, but there's sort of 3 different rankings out of these 50 plus languages. So there's Spectrum, which I just think is overall popularity, where it looks like it's 7th last above. So, and we'll just do the top 3. First is Python, second is C, and third is C++. And then you've got other languages, a few down, Java, JavaScript, TypeScript, Go, what you might expect. And then the bottom 7 go J, 4th, Elm, which I'm surprising that J beat Elm, Raku, aka Perl 6, WebAssembly, CoffeeScript, and Eiffel. So that's on Spectrum. Then we go to Jobs, aka I think Hiring Outlook for these, in which the top 3 are SQL, Java, and Python. And then J comes second last, above another single letter language, D. And right above that, just to mention a couple others, are F# and Eiffel. And then the third one is Trending, which I guess is, up and coming, or I don't know, popular, how much it's searched for. I don't know what it's actually based on, where J, I think, comes 12th last. So things are looking up, I guess, for J is what we can, there's no jobs, but there's lots of people Googling for the language.
Maybe they're more accurate than I thought they were.
Yeah.
Well, I'm sure all the fleeing D programmers will pick up J.
Yeah. I'm not really sure what to think of all this stuff. Oh yeah, and the top 3 for Trending is Python, Java, and C. Any thoughts from folks? It's hard to read into these things, especially when you've got languages like ladder logic, which I've never heard before, and Verilog, and I've heard of Verilog, but
if you find out there's a flaw in their methodology which elevates these one-letter languages, keep it quiet, please.
Or you think C is a trending language is evidence of that?
Well, I think C's going nowhere. Although it's very interesting in the low-level language space that there are, let's search quickly. If there's a ton of, I wouldn't say competitors, you could call them competitors, but languages like Nim, Zig, what's the other one that Crystal I wouldn't really call a competitor, but there's all these languages that are sort of aimed at competing in the same space.
Well, I think Nim is kind of higher level too, so Zig is the only one that's really C-like.
Is it? Yeah, I don't know much about Nim. There's another one though I'm forgetting, but does Nim...
What about Rust? Is Rust?
Rust operates more at the C++. Like if Zig is to C what Rust is to C++, I just upset, I'm sure 10% or 50% of our listeners because Zig doesn't have any of the safety stuff. But the point being is that, I think Zig is definitely trying to compete in the C space, whereas Rust is trying to compete in the C++ space. Asterisks, all the different language features and what they do well. But Nim doesn't show up. Zig, so the fact Zig, I think, is actually quite popular. Like if you're a C programmer, you probably heard of Zig, and I do know quite a few folks that are doing things with Zig. So the fact that J is on this list, I'd be interested. Was this curated by a single person, or was there a survey? Or
I think if they're looking at academic sources at all, that'd be a very trailing indicator. So you wouldn't see newer languages in there as much.
Yeah, there's another indicator called TIOBE, the importance of being earnest. And I remember seeing a tweet. I'll have to find it. Maybe we can throw it in the show note links. But someone was like, we should completely disregard this. I can't remember why, but it has something very odd. Like Delphi / Object Pascal comes in at number 13, above languages like Swift, and Visual Basic is a top 20 language. anyways, all of these, like there's PyPole, there's RedMonk, there's the GitHub ones, there's all these different ones, and they all base it on different stuff. And depending on if it's based on searches versus, the number of files that are on GitHub or lines of code, obviously that would impact.
The Stack Overflow survey is one that's actually good because they have people actually saying, I use this language. So if you can trust the respondents, then you have a better picture of, what languages do users of Stack Overflow use.
Anyways, it's interesting. If folks are interested, check out the link. And I guess we'll kind of segue into today's topic, which we will start off by deciding what we should actually title. I had suggested the title of this podcast being The Essence of Array Programming Languages. And then alternatives were suggested as, what is and what isn't an array programming language. And this is actually kind of similar to, I think, episode number 1 or episode number 2. 1 and 2, I can't remember which order it was, but one was what is array programming? And the other one was why do we like array programming? I think the why we like it was number 1.
I think that was the first one, yeah.
And then we talked about in the second episode sort of what makes a language an array programming language. So this is kind of the same thing 30x episodes later. But the reason I wanted to talk about this is that I recently, as a part of sort of the talk that I gave at these meetups, created a repo called Array Language Comparisons, where I'm comparing APL, J, BQN, Q, Nial, Futhark, Single Assignment C, Julia, R, and NumPy, which technically isn't a language, but it fits in the space. And I basically started creating these little tables of small little idioms, like how to do row reversals versus column reversals in a matrix, etc., and have run into a few things that exist in certain languages but not in other languages. And it got me to thinking, like, what really is the essence of an array programming language? Specifically, one of the things that came up really quickly is that I didn't really realize that K and Q don't have, and I think this has been mentioned on the episode, I just, it didn't stick in my memory when someone said it, is that K and Q don't have, I don't know what you call them, but true higher dimensional arrays. And because of that, they don't really have a concept of rank the same way that like J, APL, and BQN have. And from sort of diving into it a bit more, really the view of K and Q, and there's a couple articles online that talk about this, is that, Arthur Whitney really combined sort of two languages, like the array language APL and Lisps. And it almost in my mind has me thinking of K and Q as almost like a hybrid array language that has some differences from APLJ and BQM. And then looking at other languages, like it wasn't clear to me, but when I first looked at Nial, which is spelled Nial, is a language that came out of Queen's University, which, fun fact, is where Ken Iverson did his undergrad. I'm not sure if there's any coincidence or relation there. But when I first did some like array math where I, did try to calculate if a number in a vector, a rank 1 array, is less than another number, you get back a list of ones and zeros, aka booleans. But I got back like lol, like LO, and I was like, what is this? And I literally thought like I had broken something. And I at one point had thought that, oh wow, they represent Boolean arrays different from numeric arrays. But later on, it's because a numeric array is just 1 space 0 space 1 space 0, etc. Whereas this Boolean one shows up as L0 L0, which I realized is the closest and O are the closest alphabetic letters to ones and zeros, and it's like a terser way of representing or basically writing a Boolean array, which I thought, wow, this is so broken. Like, I don't want two different things. Like, they should be the same thing. But I think later on I realized that they actually are the same thing. They're just a different way of spelling it. Anyways, I'm going to stop my ramble, and we can now open the discussion to, because I'm interested to hear, what the panelists here think. What really determines, like, what are the features that if you have like a little checklist of these are the things I would expect to see in array language that you're surprised when one doesn't show up. And yeah, we'll go from there. Stephen, go ahead.
This is right. Very, very simple. I think it's kind of minimal. There has to be a vector notation. There has to be a way of writing out a vector which doesn't involve actually constructing it.
Well, hold on. How do you even distinguish between those? And so in original Iverson notation, you would write vectors as open paren 1, 2, 3, 4, close paren. Does that count?
No.
So Iverson notation was not an array language.
Oh, I'm sorry. In the original Iverson notation, was that comma a function? Like catenate, as it subsequently became?
No.
No. Okay. So my point here is, if the comma is representing catenate or join, then your vector, your array, is being constructed. And what I'm proposing here is that kind of like basic for an array language is that you can write a vector. You don't need to construct it out of operations.
Well, so part of the foundation of the APL2 family, Jim Brown's whole, one thing he was very interested in starting this extension of APL was that he said stranding should be a general notation. And as part of that, I would interpret that as saying stranding is not a notation, but an operation that works on multiple values and combines them all. So by that criterion, I'd have to say that APL2 is not, and that includes dialogue and pretty much, I mean, any actively developed APL today, NARS 2000.
Even BQN is like that, right? Even though it uses a symbol, but if you could still call that an operation.
Yeah, BQN is much more explicitly like that.
Yeah, you got to read my lips. I said vector, not array.
No, but we're only talking about vectors. So in
stranding,
it doesn't matter whether it uses an explicit symbol or not, does it?
Not after you parse it.
Right. And I would disagree anyway with that whole thing. Okay. How often do you actually write literal arrays out when you're programming? Sure, for teaching and demonstration purposes, but when you're dealing with real data, you can easily have a large program that doesn't have a single array listed anywhere. Surely removing the ability to write explicit arrays and forcing you to use concatenation or reshaping or whatever would not make APL or any other array language any less of an array language, would they?
I'm going to take it a bit of a different direction. I think of the array languages more conceptually. So although in an array language you don't have to program like you're using arrays. You can do things on a scalar level. It's quite permissible. It's not the way you would usually use them because you're sort of like I guess, driving a car around and only using one cylinder. But if you really want to do that, that's fine. The thing I find is what an array language allows you to do and actually encourages you to do is not think about scalars, but to think about groups of numbers and their relationships. And when you get to those groups of numbers, you think, well, there's no difference. If I add 1 to an array, I get 1 plus every item in the array. Even that really simple thing, you're no longer thinking about adding 1 to each item in the array. You're thinking about changing an array as a group by adding 1. And to me, that's array-style thinking. And that can be extended into very complex kind of array operations such as transpose or reverse or rank so that you can control those arrays in ways you can bend them, fold them, and move them around. But the whole time you're not thinking about the single numbers. You're thinking about the relationships between the numbers in that array. So it's the structure itself that encourages you. I don't want to say forces because you don't need to do this, but it encourages you to think about the relationship between all the different numbers and the operations you're putting on them. And to me, a language that causes you to think or gives you the tools you need to think that way is an array language.
Could we say that is implicit iteration? So for a lot of the primitives, iteration is simply implicit. You need to learn how the implicit iteration works, but once you grasp it, as you say, you stop thinking about it. You mentioned transpose, which arguably is not an iteration. I think Conor would call that an algorithm, but I think the same point goes.
So just to recap, Stephen Taylor, your observation or I don't know what the best word is, indicator of an array language is being able to write a literal vector, or for vector languages at least, which was, and I kind of got lost when Adam was saying if you go, 3-4 reshape of a sequence of numbers, that doesn't count as, like, you need to have a way for basically writing a matrix literally. So just to clear that up, or what, did you say something slightly different than that?
I did, but 3-4 reshape is an excellent example. The 3-4 is a vector, and it'd be a good example, a counterexample to what Adam's saying. You don't need to write vectors in code. Yeah, you might write 3-4 reshape.
Oh, so specifically you were talking about rank 1 arrays. You don't necessarily need to be able to represent higher dimensional arrays literally, but you should have a convenient expression that doesn't require, brackets or something like that.
That's why I limited it to vector. So vector is a rank 1 array of where all the items are the same data type. And I guess I'm really just saying, if you have a language in which you can't write a vector out, then you're not even in the running.
And so does that exclude, because there's a lot of languages, the first that comes to mind is C++. You can reach for a library utility called, vector, or one that's literally called array, but it requires you reaching for that, it's written in a library, so that doesn't count. It has to be in the language is what you're saying.
Yeah, well, I mean, there's the question of like C array initializers, right? Because when you compile the C code, it's just going to stick all the values that you gave it in the data segment of the program. It's not going to run any code in order to initialize that array. So if you have, int a brackets 3, so a 3-element array equals, curly braces 1, 2, 3. That has commas, but at the same time, it is a static notation that specifies an array rather than giving you code to be run.
Yeah, that's true of a lot of languages, actually. Like another one that comes to mind is Haskell. Like Haskell technically has a list notation, is what they call them.
Well, loads of languages have, right? You have JSON.
Well, so I guess this is not, it's...
APL is one of the few that I guess J and K would be the ones that, no, K does.
K does. J doesn't have.
Okay, yeah. So we don't have to consider, I guess, these as soon as you have this, it makes you an array language. These are criterion, criterion that you would expect an array language to have. So this isn't just because you have it doesn't make you one. So that was just recapping sort of what Stephen said. Bob, yours, similar to what Stephen said, implicit iteration. I was thinking what you were kind of talking about was the 5-cent word for it, rank polymorphism. But it sounded like you were saying more than just, being able to add a scalar and a rank 2 matrix. It was being able to operate on arrays holistically with operations. Am I capturing that correctly, or is there some other things you want to add to that of my summarization? I
think your summarization is pretty good. What I would extend it to is the way that it makes me approach a problem. So that if you actually had, I'm trying to think. I think you used one of the examples for your meetup in Toronto. Anyway, I'm not sure you did the one in New York, but it's the one with the cross in the center of the the identity matrix.
Oh, the X matrix. Yeah,
the X matrix. And to me, that got me thinking about a whole bunch of things about how I would turn around and create that matrix. Because the one I think you used was essentially you create the identity matrix and then you reverse all the rows. So you get your X and then you and them, or I think in your case, because you were trying to take the least of them, you did the floor of it between the two.
This will be coming out in the Saturday talk that I gave, but it was the max of the identity matrix and a reversed identity matrix, because then you get all the ones. And someone, I think it was you, Adam, pointed out I could do a logical or would be the same thing. But that's one way of doing it.
Yeah, and so that's sort of the base level. But what that got me thinking about is how would I create that X matrix? Because you don't have to just create it by reversing. There are other ways that you can do it. And I was thinking of, is there a way like in J using imaginary numbers, you can actually insert zeros between ones. So that if you had your top row as 1, say 3 zeros and a 1, you would say have a copy of 1J3, 3 would make the 3 zeros, and then it would go 1, but then the next one would be 1J1. And whether you could do a count going up in your imaginary numbers, so 1J1 gives you 10, 1J3 gives you 1001. Essentially, you would create a scalar, or not a scalar, a vector of your ones and zeros, but by using these imaginary numbers in an ascending or descending scale. And I haven't really played around with this, but it just started to get me thinking that way. Is there a way to actually create this X matrix a different way? And in that different way, are there advantages in solving some problems? A language that encourages me not just to go, okay, you do it this way, but what are the relationships between these different positions? Do I index into it? Are there different counts I can use? Are there different ways I can get in and change the specific spots I want from ones to zeros? And can I do that in terms of thinking about a matrix? I could go in and just index by saying this one turns to 1, this one turns to 1, this one turns to 1. That would be almost a scalar way of doing it. But I would be looking for ways to do it as a matrix. Is there a transformation I can do to create that? To me, that's what an array language allows me to do. It takes it up a different level. Not saying I always do that, but often when I'm solving a problem, if I can solve it one way, I'm always looking for that other way. Is there a simpler way that this falls out? And one of the people I think of a lot in this case, a lot of the people on this panel can do this really, really, really well. But the other person I think of always is Roger Huey, who he'd create 3 characters and do something that you suddenly realize, okay, I get what's going on here. You do a sort and you do this and you do this and suddenly something that would take what you would use maybe 5 or 6 operations can be done in 3. And there's just an elegance to that. And that's what I see in array languages. They allow you to think that way. They allow you to do those kind of things. Whereas when you go to languages that are not array language but can represent arrays, such as C++, you're doing an awful lot of work just to work the array. You're not even at the level. If you get it working, it's just like, oh, I'm done. Thank goodness that's done. I'm moving on. But an array language allows you to work with an array and then play with an array. And to me, that's what an array language does.
Yeah, I'm about to kick it to Adam. Probably, I'll see if I can anticipate what you're about to say. When I was going to say this is that while you were saying that, Bob, I had tweeted out a preview of one of the slides of my talk, and Adam had posted a couple different solutions specifically with respect to creating that identity matrix, one of which I would have never thought of and was beautiful. So I'll get Adam to explain that, and then I'll check before. Is that what you were going to say, or were you going to say something else?
No, I was just going to come with my bit on what it means for something to be an array programming.
All right, we'll cue it up. Do you recall, or do you need me to refresh what you did?
I recall this thing, but you've got to give me a link to that tweet because I don't remember what I found.
All right, I'll explain. I'm sure as I get 3 words into it, Adam will remember. He took so the way I did identity matrix was by just going iota, a number, and then you do an outer product equals, and then maxing that with the reversal row wise of it, and you get your X matrix. Adam did it by basically doing the same outer product equals, but on a different sequence. He didn't use an iota sequence. He used an sequence that was basically iota, and then taking that iota sequence, reversing it, and then taking the minimum of those 2 sequences. So you basically get like a mountain, 1, 2, 3, 2, 1. And then if you think about that and you do an outer products equal on that, you get your X matrix, which when I first saw that, I worked through it and I was like, what? That doesn't work. And then you look at it and you're like, holy smokes, that's actually perfect. But I didn't change my talk to use that example because it ruined sort of some points that I was making in my talk. So instead I said, if you're thinking there's a shorter solution, go find the tweets and you might have found one that some folks like Adam found online. But yeah, like that is when you were explaining finding different ways to solve it. Like there are ways to solve things that I would never think of in a million years. And then you just start to see these patterns. I'm not sure, Adam, if you want to add anything to that or just hop straight to what you think array languages are, or what's the essence? What do you expect to see in them?
No, I think you covered that.
If you didn't, we'll leave a link to the tweet. I'll find it later. And it is a cool exercise to work through. Yeah.
I think I'd like to say that an array language is something where the array is the core data type. That doesn't mean there couldn't be other types of collections of things, but I see a lot of programming languages that have all kinds of collections. They have sets and I don't know, node collections and tuples and whereas in array languages, I think they have in common that any collection of things is always going to be in an array. And then you have this set of powerful operations that you can do on the array. And that's your whole thing. I've heard Conor on the ADSP podcast say, like, which data type should we reach for this thing or for that thing. For the array programmer in an array programming language, that question never comes up. How should I represent this? Well, I'm going to represent it as an array because that's pretty much the only thing I've got. In K and Q, you have...
Yeah, the question is which array.
Yeah, right. And the exact structure of the array, sure. In K and Q, I've had a little bit more of a choice. And they have some tables and maps and so on. And J has some sparse arrays, but basically we're always working on arrays. And this bothers me when I have to write some JavaScript. So my JavaScript looks very not JavaScript. I do array programming there. So I'll do some query selector thing and then so I get all the nodes that match something. But unfortunately, that's like an HTML node collection thingy. I don't know, and no array operations work on it. But luckily, JavaScript allows me to write this square brackets with 3 dots in it, and magically it becomes an array, and now I can start working. Right? Same thing goes for string operations. Right? So obviously strings are just arrays of characters, but that doesn't work. But luckily, JavaScript allows me to put square brackets and 3 dots around it, and now it's an array, and now I can do my work. And then I just have to remember to do the join with a quote at the end. So because, yeah, whatever. See, that kind of thing, right? Where, yeah, you can do this in other languages, but it's not the obvious way to do it. And that, I think, is the important thing of array programming. The exact vocabulary or exact notation, that's not the main thing. But thinking in arrays and always mapping over arrays and things that reasonably can be automatically mapped over arrays are automatically mapped over arrays.
Marshall, do you want to round out our panelists' opinions on the criterion you expect to find in?
I guess I can. So I'm remembering that when I was at Dialogue and gave my talk at Lambdaconf that was mainly on the outer product, I gave at some point a definition of array programming as meaning that everything is an array. So this is true in APL and J, definitely. I think most Kers would say this is also true of K. It's the case that even if you have one number, that number is inherently an array with 0 axes. And in K, this is a little weird because axes don't mean quite the same thing, but most programmers would interpret an atom that's not nested at all as having 0 levels of nesting, and those levels of nesting are axes. So it's also a 0-axis array. And then I made BQN, which doesn't do this and has values that are not arrays. So maybe BQN just isn't an array language. But I mean, the way I think of it now is kind of really just that an array language is one where the primary influence is Ken Iverson's APL. And that's kind of just all it is, because there are several different features of these languages that come together. So you've got, you do have the focus on arrays, the use of arrays as a single data type. So there's only one way to represent things mostly. I mean, if you know your layout, there's one way to represent that layout. There may be different layouts that represent the same idea. And then there's the syntax that's based on, the particular way that Ken kind of took mathematics and made it uniform by turning everything into a function and operator. So some languages like Nial don't quite work the same. They change things to words. I think Nial actually Nial goes left to right, but it has a reasonably similar expression syntax, but it changes that up a lot. But at the same time, it's getting all its array ideas from APL, so it's still very similar. And then other things, you do have the symbols, which Nial definitely doesn't have. The use of saying that the most important functions, the ones that you use all the time, those are primitives, and they're written with one character and maybe 2 or 3 in J. So yeah, my definition would just be something where the primary influence is the APL programming language.
Interesting. So now we've got one of the criterions from Stephen being a way to write arrays as a part of the language. Bob was implicit iteration, and also too, kind of at the end of it, it sounded more of a school of thought, the way that it changes that you approach problems, and that, you know, the playfulness of the language. You see one solution, then immediately start thinking of a next solution. Adam said the core data structure being an array, and then Marshall, maybe one of the most interesting ones, is that it's a very loose definition where the main inspiration was at least traceable back to Ken Iverson's APO. So yours is probably the most generous definition that you could call the most number of languages array languages.
Well, I don't know, because it rules out stuff like Julia and NumPy, because those even MATLAB probably. I mean, those are more inspired by like LAPACK and stuff like that.
Let me toss something else into the mix here. Bob, and I guess I was saying earlier that a key thing is that a lot of iteration is just done implicitly. And I would add to that there must also be iteration primitives. So for when the implicit iteration isn't the iteration that you need, you've got primitives, operators or functions, however you term them in the language, which will specify how the iteration is to be done.
Oh no, I have to protest. That was ruled out APL 360 as an array language.
What, it doesn't have a reduce?
Yeah, but you said mapping, no?
I didn't say mapping.
You're saying that
No, I think Stephen was talking about iterators, not. I mean, I can see where you would take it to mapping, but I think if you're just talking about a way to use an operator that will allow you to do multiple things without too much effort, that's probably, is that what you're thinking of as an iterator, Stephen?
Yeah, simplest example would be each.
Yeah, but APL 360 had no each and no rank and no way and no for loops. The only way you could iterate over an array was by initializing a counter and then indexing into the array. That's very not APLE. If you weren't using a primitive that did it by itself, there's nothing you could do.
APL 360 had reduce and scan.
Yeah, but the only operands you could have were arithmetic primitives.
So let's say you define your own factorial function. You know, some languages have it built in. So you define a function which uses iota or the index generator on the argument, and then does the multiplication reduction over that. And now you want to apply this to every element of an array. And so yes, in modern languages, you've got an each. Actually, J doesn't, but you can still manage with rank.
Well, the standard library has an each.
I'm not sure where you're coming from with this. Are you arguing that APL 360, on my definition, cannot have been an array language? I'd say it's got operands, reduce and scan, and so it qualifies. I'm not arguing for that APL 360 is like a full and complete language to program in.
And Adam, you were saying though that in APL 360, the operands to the scan operator would only be arithmetic. Is that right?
Well, they could only be, but not well, it depends on what you mean arithmetic. In APL 360 and all the way to A+, what we today consider operators, higher order function, whatever, are really just special syntax. They could only, if we look at them as operators with operands, they could only take a very specific set of operands, and that's it. You could not supply your own custom function to use there.
But would you need to do that to have an array language? Like, I would think the fact that you could do it with some operands is enough to be able, within that context, to be able to think of it as an array language.
Well, in that case, instead of spelling it out separately, I would say that any programming language that has a sum function, that's just it's not actually sum. It's spelled S and then Is a reduction, S means plus. So now you've got plus reduction, so it's an array language.
What I would say is you need also have a pum function, which the P means something else, and any number of things, because the becomes something that allows you to repeat.
Mum for multiplication.
Yeah, it's
And dumb for division.
Here's a question about Q. Because Q doesn't have a concept of rank, really. So is there a term for the equivalent of rank polymorphism? Because I do know that Q and K overload the meaning of the ASCII functions, or if that's the correct word for them. I mean, in K, they're ASCII functions, and in Q, I guess there's no overloading because
they're still ASCII.
They're still ASCII, but yeah, there's a single word for each built-in function. But the fact that, because I just tested that in order to sum the rows in a matrix, you do a sum each of that matrix. So there it looks like sum or reductions really just work on sort of your rank 1 arrays, aka vectors. Is there a parallel concept of your glyphs having different behaviors depending on the, I don't know if you want to call it data structure, because I know that I'm not sure if they're called tables or dictionaries in K or Q. I know that they have sort of different behaviors if you're passing that to a ASCII function versus a vector, a rank 1 array. Is there a terminology for that, or is that sort of doesn't exist in K/Q?
Yeah, we do have a terminology for rank. It's called rank. And and what's more, it applies to functions and to data structures. So applied to a function, the rank of a function is the number of arguments that it takes. And applied to a data structure, it's the number of different indexes you can give it. So a matrix has rank 2. The plus operator has got rank 2. And it's very important, this concept. It's central to understanding explicit iteration, because because just as you can iterate, you can reduce a list with a binary operator, you can reduce it with a matrix. Worse than that, I mean, well, if you like, you probably come across the founding insight in Q or K that functions or arrays of functions, their ranges of the values of their ranges and their domains are their indices. The same is true of a dictionary. Its domain is the key of the dictionary, and the range is the values of the dictionary. If you take a dictionary in which all the values are also valid keys, then you've got a finite state machine, and you can use that to traverse a list. If you take a list of unary functions, each of those unary functions has got rank 1. My list has rank 1, so my list of unary functions has rank 2.
Now, this is the thing that bothers me.
And I can use that as a state machine to converge on evaluation.
What bothers me about this is that a function of one argument returning a list still has rank 1, right?
Yes.
Yeah, so it's very weird to me that the way that functions get higher rank is that they're just specified all at once to have multiple arguments, and the way that lists have higher rank is that they're nested. So that just I mean, it's not horrible or anything, but it bothers me that K does all this work to unify different things that have indices, but that they actually do act different. And in a more direct way, you have functions that just decide what they're doing based on the type of the argument.
Interesting. So Q does have the concept of rank and rank polymorphism. It just doesn't have a rank operator.
You've got each left and each right, which you can pair up to do pretty much what you want.
Yeah, I think Arthur has mentioned before that adding a rank operator would be possible. That, you know, once in a while he says, well, rank would be nice to have here, or something like that.
Well, I think he even said maybe time to bring back the rank operator. He did invent it after all, right?
Yeah.
Yeah, and it is an interesting thought exercise of playing the game of, well, did APL 360 have it? Because APL 360 also didn't have a rank operator. Yet it's become something that I think a lot of people would put on their list of criteria that they expect to see in an array language. If not a rank operator, at least rank, the concept of rank.
Yeah, I was going to say it had operators like, you know, reduce and scan. It's going to have a concept of rank.
Right.
And if I'm not mistaken, actually, I'm not even sure. The APL 360 have bracket access for scalar functions? I'm not even sure.
I don't think so. I think that was much later.
Okay. Yeah, so the old way of was, but see, it did have automatic mapping for scalars. Right? It just didn't allow you to specify the cells that you were going to apply on. And so it's actually fairly easy in any given situation to just use reshape to get what you want. And so if I have
and replicate possibly. Or,
no,
well,
reshape.
no, it didn't have replicate, did it?
It did have replicate, but
it had compress.
Oh yeah, right. Originally it didn't have replicate, you're right. But you don't need that. Reshape should be fine. So let's say you have a matrix and a rank, so that's a rank 2 array, and you have a rank 3 array, and you want to add them together. So that doesn't work. Right. So you want this matrix to be added to every layer of the rank 3 array. The rank 3 array being basically a collection of layers, a collection of matrices. And so what you would do then is, assuming, of course, that the matrix has the same shape as the individual layers in the rank 3 array. Otherwise, it's not going to work anyway. So all you really need to do is take the shape of the rank 3 array and use that to reshape the matrix, because reshape is cyclic. So we'll just reuse the same data over and over and over again, just stacking layers on top of each other. And now they have the exact same shape. The scalar operation will work.
And the reshape is what gives you a replicate, because it's cycling through them.
Well, it's not a replicate. Because replicate does n copies of this, and then n copies of the next element, and then n copies of the next element. And that's not. So what you could do is you could have increased the rank by adding a leading axis and then replicating along the leading axis, but without replicate, you couldn't do that. So the traditional way of doing it is reshaping.
Yeah, I think people mostly use reshape, but it is possible to do this with outer product too. And then you can add an axis to the beginning or the end by doing, you didn't have an identity function. So you do outer product addition with a vector of zeros on one side.
Yeah. Well, you could do a dyadic transpose on the outer product.
Yeah, probably.
Hugely wasteful, but again, the traditional way of doing it was definitely reshape. I've seen that code in the wild.
Yeah.
And so you could do this, and it's only really slightly awkward. It's us array language enthusiasts as opposed to the people who actually need to make money using the array languages that are all enamored with rank polymorphism and rank operator and all this fancy stuff. The people just need to get the work done. It'll take them 30 seconds extra to write that reshape at most.
But actually, the exercise we just went through, where you were trying to figure out how you would do it without replicate, and you could do it with a dyadic transpose, and you could do it with adding 0 to it and increasing the dimension that way. That whole exercise is exactly what I was talking about. When you're working with an array language, you start thinking about these things in these concepts because you have operators that work on the entire array, and you think you're not thinking about the individual numbers. You're thinking about what I can do to transform this array. It's all in the transformation and the way it makes me think. And to me, that's what makes it an array language. And it has to do with the terseness, because if there's too much work involved in doing that, I'm not going to be able to follow what you're talking about. But knowing array languages, as soon as you say dyadic transpose on a, on the matrix I'm working with, I go, oh yeah, no, that would work. That would be interesting. Probably not efficient, but I know what you're talking about.
I don't think the symbols are so important for that. If you terseness, yes, but automatically the code would become terse, even if you were to use at least relatively short names for these operations. So things like Nial, or even Q, and for all the monadic functions, if I remember right, and even K for certain things, at least some versions of K. In fact, before Unicode, when there were all kinds of encoding problems for APL, it was fairly common to have various spelling schemes for and that the code surely stayed array language code, even if you were to spell names of things.
Yeah, well, even in J, since it has a standard library, it's pretty common to write like each instead of ampersand dot greater than.
Even though that's shorter.
Yeah, I always wrote the ampersand version.
I tend to write the ampersand version because it doesn't disguise what it's doing, and that gives me more options when I think about breaking it apart. It's an under and an open, and that way it's an under, open, and close. And there's so many things you can do where the under means that you do something. You do it and then you reverse it, and that way you get that either end of the under. And that's a really powerful concept. So if you write each, that gets disguised. But one thing I was going to say is I'm the last person who's going to argue that the actual symbols are really important, because over and over again, what I hear about J is it's not nearly as beautiful as APL. And that's.
Are we talking beauty? Or are we talking array programming?
Well, that's what I'm saying. It doesn't really matter so much about the symbols to me. It's the concepts and the fact that they're short enough to be able to, and the primitives that are chosen.
Yeah, I think the primitive choice is really important. And my complaint about your definition, which, I mean, I'm not going to say it's not a valid definition, but it is, I think of it as a consequence rather than, it's something that comes out of being an array programming language instead of something that makes it an array programming language. So I think it's...
Wait, which definition are you arguing with, Masha?
The definition where an array programming is one that like encourages you to think in terms of entire arrays and operations on those. So I think of Iverson's vision as sort of one way to encourage you to bring you into this way of thinking. But I also don't think it's necessarily the only way. And yeah, I don't think that consequence is what makes something an array programming language at its core.
Oh, let me pick up on that. I think it's a really interesting point, Marshall, because Adam, you were saying earlier that you were doing array programming in JavaScript. If I understood it right, it's like when you have to write some JavaScript, you naturally favor array-based approaches. And if I was following that, it reminded me of when I was learning PHP and I got into trouble when I had to ask questions because I was reaching for array techniques and writing in functional style. And so the answers I got back to my questions were aimed at a much more experienced and sophisticated PHP programmer than I was. I mostly didn't understand them at all. It's been often said how influential Iverson and APL has been on other programming languages. And we've seen how array capabilities have been kind of copied or replicated in other languages. And when in JavaScript, for example, I find myself using the array features, I often have the experience of like, this is all right as far as it goes, but it's not the real thing. So I have a picture in my mind of the array paradigm having spread out, having rippled and diffused through the programming language space. But wherever it's moved to, it's kind of got stepped down. And so if you're working in another language, Python or JavaScript, and you're using the array facilities, it's sort of like you've got a half-broken version of them. And I was thinking, wouldn't it be cool if we wrote a book in which we took some of the core array features that have been replicated through other languages and we show them as they were originally in their source language, in APL, J, whatever, how they work there, how they combine, and then follow them into some other popular languages. And so this is how you can use the same thing in this other language or not. This is how far you can get it. So that would be of interest, I guess, to kind of computer language philologists who are interested in how these ideas spread. But it will also be a practical use to people who are working in other languages and would like to use array features and know that they're using them to the greatest extent that they're available.
Yeah, let's do that.
Okay. You in this, Conor? You know more languages than anybody I know. Hey.
I'll write a forward. How about that?
Yeah, forward by Conor Hexter, host of the ADSP and the ArrayCast.
The rest of the book written by panelists of ADSP, the podcast.
Well, I should push back against this mindset that, APL is the source and everything else is downstream. Because, one, factually, I think a lot of this stuff was developed in other languages independently, which I'm not sure whether you're saying that or not. But Lisp definitely was pretty early to getting a lot of things like map, and I think it got reduced from APL, but filter definitely got on its own. So a lot of this same style of thinking, they're pretty simple concepts. They, if you have a certain mindset approaching programming, they do just emerge. And the other thing is, I think that the thing that we're approaching is not necessarily APL. Like APL is part of the approach. So where Iverson came from was this linear algebra, and you can see that there's all sorts of he directly tells you where things come from in linear algebra. So we have the idea that like the outer product is a specialization of the inner product, which I think, Iverson definitely did eventually, completely disavow this. In J, it's called table, and there's no relation. I did the same thing in BQN. So I also think that that APL is definitely throughout the 80s, it was like working on sort of purifying this vision of array programming, as opposed to this thing that happens to be derived from mathematics. And I do hope that work continues.
No, I just want to say it does, right? By the very effect of what you're doing.
I hope so. Well, BQN's pretty much fixed now. So it's not something I wanted to spend my whole life on. And, I've at least the design of the primitives, I think, is good enough. Whoever makes the next language can add their own improvements.
Yeah, I was going to say, this is where I hop in and say, this is fantastic. This is exactly what I hoped it would be. And I now consider this podcast my personal think tank, where whenever I need a question answered or I'm having thoughts in my head, I just come here, I throw it at you folks, and then I just sit back. Because, this is...
It turns out that Conor was actually preparing for some talk at some C++ conference or something, and he just really couldn't figure out, so he threw it at the think tank.
He was literally sitting back too. He was just taking it all in.
No, this is. I did sit back for a while. At one point, I was thinking. There was a few of us at one point that were all had our eyes looking upwards at the ceiling. But yeah, this has been fantastic. The two things out of this that have really both been eureka moments, hence why I was sitting back and listening, is I think implicitly in this conversation, there's a delineation that we've all been talking about, but not explicitly mentioning what that is. At least this is, it's a eureka moment for me. Maybe other folks will disagree. But the first observation is that I think there's a delineation between array languages and Iversonian languages. And in my head, it's a Venn diagram where array languages is a superset of Iversonian languages. And this, at least for me, the school of thought and the way that it changes the way that you think goes inside the Iversonian. Well, actually, goes inside the Iversonian. Well, actually, no. Does this Venn diagram work? Maybe it's not a super. I got to slow down. Because if it's a superset, that means that everything in array language is...
If it's a superset, all the array languages would contain the Iversonian languages, right?
So you've got languages that are array languages, but not Iversonian ones in your model, right? Something like NumPy, which is not a language.
Correct. Yes. Yeah, like NumPy, Julia.
That's pretty explicitly based on the APL stuff, right? The authors of NumPy refer to APL. No?
I think a lot of it comes out of MATLAB, which is not as APL influenced as you would think. NumPy definitely has APL influences, but it's not the primary influence as far as I can tell.
And Connor's now busily Googling Venn diagrams to see what...
Well, no, now I have opened jspaint.app, which is a like Microsoft Windows Paint application from like Windows 97 style. And so because I clearly can't visualize this in my head. So yeah, the outer one is Iversonian languages. And for me, I mean, I'm not sharing my screen, unfortunately. Actually, I could share my screen and do this on my other computer.
Now he just has to draw it up.
We're seeing a circle and a circle. Well, it's not a circle, is it? No, okay.
It's not a circle, it's an ellipse.
A second ellipse.
All right, so now we've got inscribed circle inside another one. And so Iversonian. And this is where, maybe I need to think a little bit harder. Where's my paintbrush?
Yeah, the outer circle is Iversonian. Or maybe it's the area outside it. I don't know.
Right. I've got this completely backwards. Let's do this again. Iversonian languages is the inner circle.
So
I think that's what I said at first, but then somehow I confused myself. And then array languages is the outer circle, and inside is APL.
Hold on. So the title here refers to the circle that's inside them?
And then definitely on the outside is NumPy, Julia, R. So then the question becomes, is Futhark? I would put Futhark outside.
Yeah.
Yeah, Futhark is really interesting to talk about because...
And I would also put single assignment C. And the reason, and so this brings me to my second eureka moment. So the first eureka moment is that there's this delineation between Iversonian languages and array languages. And I think the things inside Iversonian languages that differentiate them from array languages are the school of thought and the way it makes you think that Bob is referring to. I don't think, in my head, this makes you ineligible to qualify for being an array language. But I do think it's essential to what sort of Ken Iverson preached with his languages. And I also think combinators are a massive part, and that's the thing is, I know, so APL, Dialog APL ended up, but, and so actually maybe there's actually a different circle here.
What Conor has drawn now is an outer group, a giant one called array languages, where he's put Futhark and single assignment C outside of that. Things like NumPy, Julia are inside. I suppose also MATLAB and Mathematica and so on would be in there. Inside that, we've got Iversonian languages, APL, J, BQN, K, I suppose, APL 360. Now, Conor has added an overlap with the Iversonian languages that he's called combinator languages, but the way he's drawn it now is it's entirely inside array languages. And that can't be right?
Oh, yeah. I see where you're going with this. You're correct. Yeah.
It has to overlap, but go all the way to the outside. Yeah.
I see what you're going.
Maybe Microsoft Paint is not the right tool for this.
Come on. Yeah. I will not entertain that.
Real programmers use Notepad and real presenters use Microsoft Paint.
That's all right. I don't have. That's the problem with Paint is I have a single stack of backspace undo, and so I have to go back 17 steps to fix this combinator languages. Admittedly, I should have done this in PowerPoint. Now that
Are there any combinator languages that are array languages that are not Iversonian?
I don't think so. So yeah, there's maybe even a nicer one of these. But for we're good with this now. And I might put.
Where does Cozy fit in here?
I don't know enough about Cozy. I might put Haskell down here. And so that's actually the ones that we haven't listed yet. So Q, I don't know enough about Q, but I don't think they have a rich support for combinators. Like, do they have the
Q and K?
Neither does K. So
I'd like to two exhibits here. One is in K. It is fairly easy because K has functions as first-class citizens to write your own combinators. People generally don't, but there's nothing preventing you from. Another exhibit would be APL2, which does have operators, user-defined operators. It doesn't have very many built-in ones, but it's very simple in APL2 to define your own combinators so that you have all these combinators that you want. Whereas in APL 360 and even APL Plus, I think, you cannot define your own operators, and therefore you cannot create combinators. So when I'm trying to make a distinction between the ability to make combinators and comes with combinators out of the box. You want to distinguish between those?
Yeah, and I think what's built in should be the focus, because
and even to answer, like on top of built in, this is like the answer to a conversation I had once with a bunch of C++ folks, a few of who were sort of functional programmers, and it was like, what makes a language functional? Like, honestly, this whole podcast is similar to what is a functional programming language. This is the equivalent, but what is an array? Yeah. And I wish more podcasts, like that's the thing, is Lambdacast, I think they had a kind of episode on it, but not really free-form discussion because that's the thing, is at one point, a couple folks were saying, I disagree, but don't want to invalidate. I think when it comes to this, everyone is allowed to a certain extent their own opinions of what they think a functional language is or an array language is. I think it's just a super interesting discussion for what are the criterion that people expect. And for me personally, when I hear Bob talking about the way you think, I completely am in love with that idea of the array quote unquote languages, but have sort of realized that I also think other languages are array languages that don't do that, but still have a lot of the same properties that are a superset of the properties or a subset of the properties that I would look for in sort of the quote unquote Iversonian languages. And I think when it comes to languages like Dialog, APL, J, and BQN, it's very, very idiomatic to make use of the combinators because they're built in. Also in Haskell, you don't have a full set of combinators, but it's also very idiomatic to use, flip, which is the C combinator, and join, which is the W combinator. And there's something called app, or the applicative functor, which doubles as the S combinator. These things are super, super common to be used in Haskell, even though they don't come with the language. There's only one that comes with the language, which I believe is the B combinator, which is the dot operator. So I think it's less, does it come as a...
Hold on. If you install Haskell, so all you have to do is write an import statement in your program and you get it.
Correct.
Right?
But
so it comes with the language, but it's not...
It's in a library. But I think it's less important whether it's in the language versus in the library. The question is, what is considered idiomatic use? Is the average, Haskell or BQN or APL programmer? Because that's the thing, is when I was having this conversation with the C++ devs talking about, what is functional programming, that's what someone's response is. Like, technically, where does Swift fall? Or where do languages like F# that are both object-oriented and functional? And even for that matter, Haskell, it's a pure functional language, but there are corners of the language where you can do a bunch of unsafe stuff and start writing code like C. And his response was that because the majority of Haskell programmers program in a very sort of pure functional way, it's considered a pure functional language. But if the norm was for everyone to be doing like C low-level stuff and pointer mapping and whatnot, it wouldn't have the same reputation. Anyways, that's one take. Whether it's correct or not is a different conversation. I'll stop talking though for a sec. Do people have comments about anything that I've said in the last couple minutes?
It sounds to me like what you're talking about though is the paradigms of the languages, right? There's an array programming paradigm. There's a Lisp type programming paradigm. There's object-oriented type paradigm. Whenever you're talking about paradigms, you're talking about ideas that might not be as strongly represented in the other languages, but the concepts could be there. It's just that that's not primarily what that paradigm, addresses or works with. And to me, it's interesting, like with combinators, you see them across different paradigms, that you get functional programming like Haskell, sort of in terms of combinators similar to combinators used in APL or J or BQN. But it's almost like combinators are something that could be considered cross-paradigm, but actually maybe they are a different paradigm as well, as opposed to, the lambda calculus, which is, again, a different paradigm for looking at operations that way.
Obviously, a programming language needs some kind of sequential storage, right? Every programming language pretty much has arrays of some sort or lists of some sort to store data. But many languages don't really have any facilities to directly work on arrays. Some don't even have some, right? You have to loop over and add up. So having arrays is definitely not an indicator of being an array language. Every language has arrays of some sort. Question is, so a lot of languages have some facilities for dealing with arrays, if nothing else, reversal or summing or things like that. If you take away all of those abilities, those languages will largely remain functional in the sense that you can still use them. You have to write something differently, but you could still use them. If you take away the ability of a language to deal with arrays directly, and that causes the language entirely to fall apart, like you can't do anything anymore, then I would say it's a proper array language, possibly Iversonian type thing. And I would say that's the case for all of these APL type languages and Q and K. Right? If I remove the ability to operate on entire arrays in Q or K, you can't do anything anymore.
All right, we're at the hour and 20-minute mark here, and we got to start to wrap this up. So we will come back to this. This episode will be titled, actually, what is it going to be titled? We'll figure out the title offline. And there will be a second part 2 of this that we'll call Iversonian languages versus array languages. Maybe that'll be full stop, or maybe we'll do versus combinator languages versus functional. We'll get all the SEO optimization. But before we end, I think we should talk about very quickly Futhark and Q and K. So I think Q and K will be quicker. Where do people think Q and K belongs? I think it's outside the combinator languages circle. The question is it inside the Iversonian languages circle?
Well, I think it's actually more obviously an Iversonian language than it is an array language, because all these NumPy and R are definitely pretty focused on multidimensional arrays. Obviously, APLJ and so on are. And K and Q, along with Julia, are mainly focused on one-dimensional arrays, I think. Like Julia, if you just ask for an array, you're going to get a one-dimensional one, right? Like that's a default. So I might even say that, yeah, Q and K are Iversonian, which is the category that I've been calling array languages. But they don't fit into this other category, depending on how strict you are about the boundaries. Certainly you can program as though you're using multidimensional arrays. You can think of them as multidimensional arrays, but they don't work in quite the same way as APL and J arrays.
Should we quickly hear from our resident KQ expert, Stephen? Do you want to agree with or not agree with the fact that Q and K are being placed in the Iversonian languages?
Yeah, absolutely. Solid core Iversonian.
All right. We'll do 60 seconds from Marshall Lochbaum on thoughts on Futhark, and does it live outside of this? I've for folks that are watching this on YouTube, you'll see that it's living outside all the circles right now. Go ahead, Marshall.
Yeah. So the Futhark does call itself an array language. But what I see from reading is this is much more about how it's implemented than what the programmer is exposed to. But it's interesting because these levels like have a lot of interface between each other. So on the programmer side, Futhark looks like kind of a restricted ML family language. It's a lot like Haskell or OCaml or all the other stuff in the ML family. But in order to make sure it runs on GPUs, you have a lot of restrictions on like what your types can be, and it has to a lot of things have to be possible to be resolved when it compiles. So when you're programming, you end up thinking about, you know, how are all my arrays laid out? What are, I mean, you have to say what type is this, and the type has to fit into an array model, basically. So in one sense, it's just like a sort of like Haskell that's been cut down to fit into an array model. And in another, it's like array programming that you express through Haskell. So I don't know quite what to make of that.
Yeah, I didn't even really get to talk about my second Eureka point. The first one was the delineation, and we're going to do a hard stop in a couple minutes here because, yeah, we've definitely gone over. But like I said, we'll promise part 2 of this, which we'll call something similar. And the preview of the second Eureka point is that, you know, Stephen mentioned implicit iteration. We've talked about rank polymorphism and just not having to be explicit about your indices. And I realized that rank polymorphism, I have semantically attached to the rank polymorphism model inside of JBQN and Dialog APL. But I think really rank polymorphism is just an umbrella term for any way to deal with rank polymorphically. It doesn't necessarily need to be, and the secondary thought to that is that, you know, a lot of these are leading access rank polymorphism. So you could acronymize that to LARP. But there's also trailing access rank polymorphism. And then there's also the rank polymorphism of Julia and NumPy, where the default of your operations is just to reduce everything to a single number. So when you sum a matrix, you just get back a single number. Whereas, you know, and I don't know what you call that. I've in my head been calling it axis agnostic, but it's really only axis agnostic by default. And then, you know, I think I said something in a past episode where I said, oh, that the reverse function of NumPy flip doesn't even work correctly. That was wrong. It actually just calls the two different, I was using axis equal to 1 and 2. Axis equal to 0 is, so axis equal to none is the default. That sums everything into a matrix. So that would be the equivalent of raveling something and then summing it up in our Iversonian languages into a scalar. So if you sum up a matrix in NumPy and Julia, the default is that it gives you back a single scalar, rank 0 number, rank 0 array, which is the equivalent of raveling or raising something in our languages and then summing it up. And if you then do axis equals 0, you get column-wise summation. I think I switched. I was going from reversing to summing, but so yeah, reversing will reverse column-wise, and summing will sum column-wise with axis equal to 0. And then axis equal to 1 is the row-wise one. And I think in a past episode I said I tried to do axis equal to 2 and it doesn't work, and they just have a hard-coded, you know, flip UD for up-down. So even though that is a hard-coded thing, they do actually have the general concept of rank. It's just backwards. Anyways, I'm going to stop talking. We'll talk more about the fact that I think rank polymorphism is this umbrella term, and if you have any facility in your language for dealing with rank such that basically you don't have to explicitly map, which is what Futhark does, and which is why I have sort of Futhark outside of the array languages, is that I was very surprised that when I got to Futhark, I had, in order to sum up the basically lists of your lists, because they represent their matrices as just like lists of lists, you end up having to map like you do in Haskell or any sort of functional language. Any last final thoughts before we wrap this up, which we're close to this being our longest episode after I said we were going to keep these short, but then I got carried away with my Venn diagram. It's all my fault.
And I'm not sure what we say to those people who might only be listening to this on their podcast during their walk or something, because that's how I'm going to listen to it. If you get a chance, I mean, the diagrams and everything are fairly, they show things fairly well. But I don't think, having watched people create the diagrams, there's any way that you would be able to follow it on audio. There will be, we'll put a link up for the YouTube of the actual video of the diagrams being created. And honestly, that's fairly entertaining as well. So, I mean,
But even if you can't watch the video, we can certainly kind of can save this, and we can link to that image. Like, say, if your bandwidth can't handle that,
Well, I'm about to tweet this. I'm about to tweet this out in like 3 seconds.
we'll link to the tweet.
and I plan on creating a polished version of this, and yeah, definitely look forward to the part 2 of this, because we haven't really even talked of all the languages, single assignment C, and there were some topics I was hoping to get to, like representing Booleans as ones and zeros and small things like that, because there's a bunch of things that I think we could still continue to talk about in this sort of domain.
I just think we should all be listed as collaborators on your dissertation when it gets published.
If it ever gets published, yes. And no, I'm not doing a PhD currently. That was a joke from Bob. But if I ever do, I'll put this.
It'll probably be on this.
Yeah. All right. Any last thoughts, comments? I guess I said that a second ago. Folks can contact us at Arraycast.
Contact at arraycast.com. Show notes will be in, and there will be a YouTube up that people can take a look at and follow this along. Or, as Dan pointed out, we'll put a link up to the actual still graphic as it is now, probably, because it's sort of complete and is interesting.
Well, I'd say it's probably complete with some definition, but I'm sure if once I post this, people are going to say, "How come you didn't include language X?" And sure, that'll be good for people commenting and whatnot. But yeah, I think it'll be interesting as a reference going forward too, because hopefully we can get some folks to talk about languages that aren't really represented, like Nial, and even languages that are array languages but outside of Iversonian, because I think definitely we've been focusing on the Iversonian languages rather than sort of the broader picture of array languages. So it'd be cool to talk to folks, on Julia and NumPy and R and stuff like that.
So I'd like to just mention that APLWiki has a couple of family tree of array languages, which is not really family as much as showing that there's some influence going from here to there. That might be, if you like this kind of content, you might like that.
Yeah. And while we're mentioning links, Marshall himself actually also has I think we've mentioned this before on the podcast, before you were a regular panelist, I think it's the functional programming post, but it has very similar to this Venn diagram of functional languages and array languages, and sort of how BQN fits into that Venn diagram. But it also mentions a ton of other ones, it's a super interesting read if you like this kind of programming paradigm kind of stuff. All right. With that, we will say happy array programming.
Happy array programming.